In the early 1970s, the laser had just been invented, and Dan Walls had just returned to New Zealand having done a PhD in a field called quantum optics. This was a whole new field, and he brought an enthusiasm for this subject with him, with which he managed to infect not only the students around him, but also colleagues like us. So in 1972, Dan moved away from the University of Auckland to the University of Waikato.
And I followed him there, and over the next half a dozen years, many of the foundations of quantum optics were established there, in particular and initially ideas for observing the particle nature of light.
So the international community was sufficiently impressed that when Dan and I organised a series of summer schools and conferences over the next 20 years, we managed to attract a stellar array of people, many of whom have gone on to run their own institutes, and some of them have indeed become Nobel Prize winners.
The Dodd-Walls Centre for Photonic and Quantum Technologies is one of a handful of national research centres in New Zealand. It's hosted by the University of Otago, New Zealand's oldest university, and is distributed over 6 of the universities in New Zealand, the largest of the partners being Auckland University, where we are today. We now have real critical mass. We have 130 PhD students, nearly 50 staff, spread across 6 universities in New Zealand. So with our backgrounds in quantum optics and atomic physics, the overarching theme of the Dodd-Walls Centre's research is the interaction of light with matter at potentially the smallest scales.
One of the things the Dodd-Walls Centre does really well is marry esoteric physics like cold atoms or tailored laser pulses with things that real people need, like more efficient and cheaper medical diagnostics, or cell phones that are more powerful, or a more sustainable dairy industry.
I mainly work in biomedical optics and primary produce, so I work with the primary industries to detect bacteria, to avoid food wastage, for example. But I also work with health professionals to detect very, very early signs of non-communicable diseases.
So my PhD is all about looking at ultra-fast laser pulses to cut and machine bone for orthopedic surgery.
One of the most important results that have come out of my theme is arguably our development of models that allow us to simulate so-called micro-resonator optical frequency combs, which are having a huge influence around the world because these kind of devices have many potential applications, for example in telecommunications or spectroscopy and so on.
At the University of Otago, we achieved the Southern Hemisphere's first Bose-Einstein condensate. This was very early in the piece for studies of these ultra-cold gases, and really has marked New Zealand as one of the key centres for development in this field.
So theory in New Zealand is now having a really big impact internationally, and our experiments are carving out some really interesting niche areas for work.
We partner with the likes of the Centre for Quantum Technology in Singapore, the Joint Quantum Institute in the United States.
We now have, in many ways, the best performing quantum memories for light.
What's really nice about New Zealand, it's a village without being too constrained. So you could compare New Zealand to a spin-out compared to a big old company. So everything happens a bit more quickly, a bit more dynamically. And so it's a country where it's easy to find collaboration. So you will get someone who will come to see you because they know that you can do something useful for them.
We really support international students. International students only pay domestic fees, and they're also treated as domestic students for all scholarships.
Now that I'm in New Zealand, it's everything that I expected, but so much more. So like the outdoor adventures, they are so incredible. The hiking, the mountains that you can explore, the lakes, the rivers, oh, the beaches, just everything, every place you go is absolutely gorgeous, and that's just spectacular to be a part of.
The students in my group are really interdisciplinary. There's physicists and engineers and chemists and biologists, and they love what they're doing. Of course, they win awards doing it, but really for them, it's the problem solving coupled with making a difference, and that's one of the things the Dodd-Walls Centre is really good at enabling.
I'm really excited with the prospect of taking my research to the next level and bringing it into industry and commercializing it through a spin-off company.
Kiwis are great DIY people, and that inspired me to get more hands-on with equipment in my lab.
The Dodd-Walls Centre has helped me to travel as part of my research. So I got to go to a Gardiner research conference on photochemistry in the United States last year. And next week I'm going to Hong Kong to work on some really cool experiments as part of my research project there.
Well, right from the very start of the Dodd-Walls Centre, education and public outreach was seen as a core part of the work that the centre did.
Working with young children, especially 4, 5, 6-year-olds, and seeing their sort of enthusiasm and passion for the science that we're doing and kind of seeing things through their eyes really gives you a new perspective on science.
So in New Zealand we acknowledge we're a long way from anywhere and we're used to travelling, but that means that we've built into the centre a generous programme of support for visitors. So if you want to come to New Zealand, come and visit us.